Okay, what we've got here is a very strange data set. Why is it so strange? Well, if we tried to analyse it, I reckon we'd find the median is somewhere in here. We'd find the mode doesn't exist. The mean would be about a 40 something. But look at these end values. Now, what does the data look like without those end values? Okay, interesting. Now let's imagine these are test scores in a maths class. How would you describe how the whole class is done? Well, I worry about these three. Perhaps they've been absent. Perhaps they need to move down a set. Or perhaps they've just found it tricky because they haven't yet watched the videos. These three are doing really well. Do they need to move up? Do they need some extra challenge? But how would you describe the class? Well, you'd want some way of describing this section in the middle, because this really describes the group. Now the range of the data is 86. That's 89 take away 3. But actually, if you were to describe how spread out the data is, you'd want to say a lot of it is very close together. So, what we're going to do now is learn some new terms. So, a couple of years ago, the UK government changed tuition fees. And when you study the effect of tuition fees, they look at things by income decile, which means they split people's income levels into 10 groups. Now this is to ensure that the poor, or the less affluent, and the rich, the more affluent, the deal is fair for everyone. So, given that our ends of our data here are quite extreme, we're going to cut our data into quartiles. So into quart is 4. So, first off, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 bits of data. So line them up from 1 to 15. How do we find the middle? Well, that's 14. So we want 7 each side. So the 8th bit of data is the middle. 1, 2, 3, 4, 5, 6, 7, 8. So our median is 43, which is the 8th piece of data. Now, we're going to introduce the following terms: lower quartile and upper quartile. Now, here's a set of data. You'll have a lowest value. A quarter of the way in, you will have the lower quartile. Halfway in, or 2 quarters, you'll find the median. 3 quarters of the way in, you'll find what's called the upper quartile. And then you'll find at the end the highest value. Can you see where I'm going with this in terms of our data from the original setup? Can you see that perhaps if we were to find a way to eliminate those meddlesome lowest and highest values? Well, if the 8th bit is the median, the 4th bit is the lower quartile, because it's half of the middle. And then the upper quartile is the 12th. Just take a minute to check that. The 8th is the middle, so the 4th is the lower quartile, and the 12th is the upper. So the 4th piece of data is 36. The 12th piece of data is 48. I'm now going to introduce you to a new term, which is the interquartile range. So, this is the upper quartile subtract the lower quartile. What this is going to do is give us 48 subtract 36, which is 12. So in this situation, the range of our data, or the range of the middle half of our data, is just 12. So our data is all fairly similar. Our overall range was 86. So we had some outliers on either end of the data set. So by finding the interquartile range, we can now look at describing the middle half of the data. And we do it from going a quarter of the way in up to 3/4 of the way in. We find the median's position, half it to find where the lower quartile goes. The upper quartile, if that's 4 apart, goes for the other side. 4, 4. And then we locate the numbers. And our interquartile range is the distance between those two. So, in the next part, we're going to look at finding the interquartile range for a cumulative frequency curve. We're going to look at then at how we would also find other values on a cumulative frequency curve and some special trick questions. And then look at a diagram that shows this data in a linked way.